welcome back to the deep dive. Everyone's talking about making large language models think more. And today, we're going deep on a paper that's tackling exactly that.
Oh, yeah.
It's called
I knew this one.
Deliberation in Latent Space via Differentiable Cache Augmentation.
Catchy title, right?
It is, it really is.
But it's a fascinating area. There's this drive to get LLMs beyond just generating text to make them really think.
Right, exactly.
More deliberate and insightful problem solvers, you know?
Yeah, and this paper proposes a pretty different approach to that.
It really flips the script. It's not about the output, generating all those reasoning steps. It looks at augmenting the LLM's memory.
Okay, so before we get too far into the weeds,
Sure.
we should probably define what we mean by augmenting the LLM's memory.
Yeah, good point.
So think of the key value cache, like the LLM's short-term memory. It's where it stores all the information it's recently processed.
Right. And the paper's authors are saying, if we can smartly add stuff to that cache,
Okay.
we can actually guide the LLM's reasoning in a more efficient way.
Interesting.
It is.
So instead of making the LLM write out every single thought,
Yeah.
we're kind of giving it a more organized workspace to work with.
Exactly. And it's like,
That-
imagine a detective trying to solve a case, right?
Okay.
If their desk is totally covered with random papers,
Yeah.
super hard to connect the dots.
Yeah.
But if someone comes in and organizes it, like puts things into meaningful piles,
Yeah.
suddenly they see the patterns.
Oh, so in this case then, the organizer is what they're calling the coprocessor.
You got it. This coprocessor,
Okay.
it analyzes the text the LLM is working on, and it generates these latent embeddings.
Okay, latent embeddings.
It's a mouthful, I know.
So think of these embeddings like concentrated packets of information. It's like cliff notes for the text.
Yeah, like the key takeaways.
Exactly. The key relationships, concepts that the LLM should focus on.
And the cool part is,
Yeah.
the coprocessor can make these embeddings offline. So it's doing work ahead of time.
That's interesting.
Yeah.
It's kind of like having a research assistant
Uh-huh.
who pre-reads all the material
Totally.
and flags the important parts
Yeah.
for the LLM to really dive into.
So no more figuring things out on the fly.
So much more efficient then.
Huge advantages in terms of speed and efficiency.
Now, they didn't just theorize about this coprocessor.
Right.
They actually tested it out.
Yeah, with a powerful LLM called Gemma 2.
Gemma 2.
Mm-hmm.
And the results were really impressive.
It's wild. They saw improvements across all sorts of tasks.
Wow.
And they didn't even train the coprocessor on those specific tasks.
Hold on.
Yeah.
You're saying this coprocessor wasn't specifically trained to solve math problems,
Nope.
but it still helped the LLM get better at math.
Exactly.
That's amazing.
It is. On GSM-8K.
That's a math.
Yeah, the math benchmark, it boosted accuracy by over 10%.
Wow, that's huge.
Yeah. And on a general knowledge test,
This is the MMLU.
MMLU, it was a 4.7% improvement.
Okay, so clearly this approach is working.
Definitely.
But I'm curious, how does this coprocessor learn to generate those helpful latent embeddings?
Good question.
It's not like we can just say, hey, figure out what's important.
Right. It's all about training.
Okay.
It's trained alongside the main LLM. It gets a chunk of text.
Yeah.
And its job is to make embeddings.
Okay.
That'll help the LLM predict what comes next.
So it's kind of like giving the coprocessor a puzzle. Like, here are some pieces, figure out how they fit to predict the missing ones.
You got it.
And the better it gets at predicting, the more insightful its embeddings become.
Exactly. And by designing the training process carefully, they were able to guide the coprocessor to really understand the text.
This is all fascinating.
It is.
But why should our listener care about this?
Well, if you're working with LLMs even a little bit, understanding this stuff can help you see where the field's going. It's not about just making LLMs bigger. It's about making them smarter.
More efficient.
Way more efficient.
And that has implications for anyone using LLMs.
Right.
Whether you're building apps, analyzing data, or just trying to keep up with AI.
It's about the potential of AI to really reason.
Yeah.
Not just generate text, but to solve problems like we do.
That's really interesting.
It is.
I'm excited to hear more.
Yeah, me too. This is where it gets really interesting.
Okay.
Imagine LLMs are always running these coprocessors in the background, like having a research team constantly prepping information.
So the LLM could be thinking
Yeah.
even when we're not using it.
It is pretty wild.
That's mind-blowing.
It is.
That's a little scary.
Yeah, but think about the possibilities.
Okay, yeah.
They could even start to
Yeah.
deliberate without being prompted. Like
Yeah.
they're always making connections and generating insights.
So it'd be like an AI that's always learning,
Constantly evolving.
even when we're not interacting with it.
Exactly.
Okay. But
Yeah.
we've talked about these embeddings as these information packets.
Uh-huh.
But what do they actually look like?
That's a great question.
Like, are they just words or numbers or?
They're not words, not exactly.
Thanks,
They're
Bob.
vectors, which are basically
Right.
lists of numbers. And each number represents some aspect of the text's meaning.
So it's like a code
Yeah, you could say.
that captures the meaning.
In a way the LLM understands.
But how do we know
Mhm.
that these embeddings are actually helpful?
That's where the training comes in.
Okay.
The coprocessor learns to make embeddings
Right.
that are designed to improve the LLM's performance.
So it's not just randomly generating these vectors?
No, it's learning what the LLM needs to succeed.
Interesting. So the coprocessor is being trained at the same time as the LLM.
Exactly. And the research shows that more embeddings
Yeah.
generally leads to better performance.
So more is better.
Up to a point, of course.
Right. There's got to be a limit.
There is. You don't want to overload it.
Yeah. Too much of a good thing and all that.
Exactly. The optimal number depends on the task
Makes sense.
and the LLM's capacity.
Okay. Now,
Yeah.
the researchers compared this approach
Uh-huh.
to other ways of improving LLM reasoning.
Right, like using pause tokens.
Remind me, what are those again?
They're like special symbols
Okay.
that you put in the text
Uh-huh.
to tell the LLM to slow down.
Like take a break and think.
Yeah, think things through.
Got it.
But what they found was this coprocessor approach did better.
Consistently.
Yeah, across the board.
Why do you think that is?
I think it's the flexibility.
Mm-hmm.
The coprocessor makes these embeddings
Yeah.
based on the specific text.
Hello?
Pause tokens are fixed. They don't adapt.
So it's like having a personalized guide
Uh-huh.
versus a general set of instructions.
Exactly. And that adaptability is key.
So we're not just making LLMs think more.
Right.
We're making them think smarter.
More efficiently.
This whole conversation is making me rethink how we use LLMs.
Me too.
It's like, right now, we treat them like tools.
Mhm.
We give a prompt, they give an answer.
Yeah, very transactional.
But with this coprocessor, it's more dynamic,
More interactive.
a back and forth,
Imagine LLMs constantly learning in the background,
even where we're not using them.
analyzing data, making connections.
It'd be like having a constant brainstorming partner.
It's someone who's always thinking about the problem.
And when we need the LLM,
Uh,
it's ready to go.
with all this pre-processed knowledge.
Wow.
Right. Think about scientific research.
Okay.
LLMs could help scientists analyze tons of data.
Or in creative fields,
Yeah, sparking new ideas.
the possibilities.
They are endless.
But
Yeah.
no technology comes without its downsides.
True, there are still challenges with this approach.
Like what?
Well, training the coprocessor is tricky. It's not just feeding it data.
There's an art to it.
You could say that.
Like fine-tuning a recipe.
Exactly. And then there's the bias issue.
Oh, right. We have to be careful about it.
We do. The coprocessor could introduce bias.
Even though it's behind the scenes.
Yeah, it's still shaping the LLM's thinking.
That's a good point.
It is.
And it's a good reminder for our listeners, while we're talking tech,
Yeah,
we need to remember the bigger picture.
the societal impact.
Exactly. Ethics are important.
Absolutely. AI should work with human values.
Well said. Okay,
Yeah.
this has been fascinating.
It has.
But I want to hear about specific examples.
Yeah, let's get into some real-world case studies.
Okay, in the final part of our deep dive,
We'll see how this coprocessor has been used.
to actually improve performance on real tasks.
Let's do it.
So we've talked
Yeah.
about this coprocessor and how it can help LLMs think.
Right.
But can you give us some concrete examples?
Absolutely. So one of the tasks they tested was mathematical problem solving
Okay.
using the GSM-8K benchmark.
Ah, GSM-8K. That's the one where the LLM got a 10% boost just from the coprocessor.
Yeah, that's right.
But these aren't your simple addition problems, are they?
No, these are complex word problems.
Multi-step, like the ones that make you think.
Exactly, the kind that really test your logic.
So how did this coprocessor,
Yeah.
which wasn't trained on math,
Uh-huh.
help the LLM solve them?
Well, it seems like it was able to pick up on those numerical relationships,
Interesting.
even though it wasn't specifically taught math.
Like it developed a sense for numbers.
Yeah, sort of intuitive
And
understanding.
then it put those insights
Yeah.
into the latent embeddings,
Exactly. The embeddings acted like little hints,
guiding the LLM.
helping it focus on the right information.
Wow, it's like
Yeah.
the coprocessor gave the LLM a crash course in math.
And the results were impressive.
10% accuracy boost.
That's huge.
Okay, so we've seen math. What about general knowledge,
Ah, yes. The MMLU benchmark.
which covers like
Everything. Science, history, literature.
even law?
Uh-huh. It's a really broad test.
And again, the coprocessor wasn't trained on these specific topics.
Nope. But it still helped. It
Huh.
seems like it built a knowledge map in those embeddings.
A knowledge map.
Yeah, capturing the links between ideas.
So it's not just giving the LLM more facts.
Yeah.
It's helping it understand
Right.
how those facts relate to each other,
Exactly. It's giving it a framework.
like a mental filing system.
You got it.
This is really showing the power of this approach.
It is. It's not just about data,
It's about adding structure.
adding insight.
Okay, now for our techie listeners out there,
Mhm.
can we talk a bit about how this coprocessor is actually trained?
Sure. So as we mentioned, the coprocessor is like a mini LLM,
Right.
but it works specifically on the key value cache.
Okay, the LLM's memory.
Exactly. It's a specialized tool.
But how do you teach it?
Well, they use a method called a head token prediction.
A head token prediction.
Uh-huh.
What's that?
So basically, they feed the coprocessor some text.
Okay, like you would with the main LLM.
Right, but instead of generating text,
Yeah.
its job is to create those embeddings
And it's trained to predict the next token.
based on the current cache and the embeddings it makes.
So it's always trying to anticipate what's coming next.
And that helps it refine those embeddings.
The better it predicts.
The better the embeddings.
Wow. So it's learning the patterns of language?
And to make the training even more efficient,
Yeah.
they use some clever techniques like
Yeah.
multi-position augmentation.
Okay, multi-position augmentation, what's that?
It's training the coprocessor
Uh-huh.
on multiple positions in the text at the same time.
So it's like giving it multiple perspectives.
Yeah, like cross-train it
To help it understand the text better.
and create more generalizable embeddings.
This is really blowing my mind.
It is fascinating, isn't it?
It feels like LLMs are becoming more like thinking partners.
I agree. The possibilities are huge.
The researchers talked about some future directions,
Yes, like exploring different coprocessor designs
maybe even more effective ones,
and making them even more adaptive.
so they can take the user's goals into account.
That would be amazing.
And they even mentioned using multiple coprocessors
Like a whole team of AI experts.
working together.
It's really exciting stuff.
Well, we've covered a lot in this deep dive,
Yeah.
from how this coprocessor works
To its impact on LLM performance.
and even what the future might hold for AI.
It's been a great discussion.
To all our listeners out there, keep those brains buzzing, stay curious, and we'll see you on the next deep dive.